Hello everyone. Welcome to this learning video on geometry modeling in STAR CCM+. This video is part of the course by Learn CAX on CFD modeling using STAR CCM+. In this session, we will see and learn various geometry creation and modification options in STAR CCM+. CAD geometry is the starting point of any CFD analysis. Hence, it is very important to know how to create, modify and repair geometries for CFD. So let us begin this learning session on geometry. We understand it clearly by now that any CFD simulation requires a CAD model to start. So the first question is how to create geometry in STAR CCM+. Do we always have to create a geometry from start in STAR CCM+, or can we import already created geometry model? Let us see how to do all this. For all the geometry creation needs, there is an inbuilt feature in STAR CCM+ called 3D CAD. This is a feature-based parametric modeler within STAR CCM+. In 3D CAD, we can build geometries from scratch. These CAD models can be later used as geometry parts for integration with the meshing and simulation process. Various CAD operations like sketching, extruding and cutting are available. There is also design parameters. Using this, we can modify the 3D CAD model from outside of 3D CAD. This way, we can solve for a particular geometry, change the size of one or more components, and rerun the case quickly. When we open 3D CAD and create any entity in it, we should be able to see what the creation is. This can be seen in the 3D CAD view scene. When we open 3D CAD for any operation, the scene opens up automatically. A sample scene image is shown here. There should be some way to check whether the geometry created or imported is appropriate for using CFD analysis. This can be done by using geometry validity check. STAR CCM+ can check the validity of geometries within the 3D CAD module. This should be done before setting up a simulation. This is highly critical when using imported geometries. In any CAD creation operation, it is very helpful if we can see a preview before we finalize any operation. This will help to know whether we are on the correct path or not. Is there any such feature? We can do this using the 3D CAD feature previews. For most 3D CAD features, STAR CCM+ displays a preview of the expected result in the 3D CAD view scene before you complete the action to create the feature. An example is shown here. Till now, we have talked a lot about features. We use the word feature everywhere. But what exactly is a feature? A feature is any entity of creation in 3D CAD. STAR CCM+ uses a feature-based modeling approach within 3D CAD. We create CAD model in 3D CAD using a series of operations or features, each of which represents a particular action. For example, a sketch feature is added to the model when we construct points, lines and curves on a sketch plane. An extrude feature is added when we select an existing sketch feature and extrude it in a particular direction. The entire set of features that is used to construct a model is stored in the feature tree in the order that we created them. The next concept to understand is the feature tree. A feature tree is an ordered sequence of all the actions or features that are required to build the final model. Feature Manager node is a parent to all feature nodes within the tree. The feature tree is dynamic in nature. This means editing an existing feature in the tree impacts the outcome of subsequent features. Also, the result from one feature acts as an input for the next feature. At start, the feature tree contains nodes for each of the three canonical sketch planes. This is referred to as the initial state of the feature tree. As we go on creating more features, the length of the feature tree becomes longer. Once we create a sketch feature, there is always a need to go back to it and modify for further operations or corrections. We will review some edit feature operations here. Properties of the feature can be altered, such as angle of revolution or sketch dimension. First operation is deleting a feature. This will permanently remove a feature from your 3D CAD model by deleting it from the feature tree. Next is renaming a feature. We can rename most feature nodes in the 3D CAD feature tree. This capability is useful for complex models containing many features. Another interesting operation is rollback of feature. What happens when we roll back a feature? This will temporarily deactivate that feature and all subsequent features. We can still insert new features in the feature tree. These features are placed directly above the rolled back features. Contrary to this is roll forward. What does roll forward mean? Rolling forward to a particular feature reactivates that feature and all features that come before it. Then there is roll to end. What does rolling to end do? Rolling to the end reactivates all the features in the feature tree. We can also suppress a feature. Suppressing a feature deactivates it and any features that depend on it. Let us see the different feature states in STAR CCM Plus. First is rolled back. It is given by this sign. This status indicates that the feature is further down the tree than the rollback point and so is not executed in the CAD engine. Then we also have suppress status. A feature will have this sign besides it. This means that the feature or its parent feature is suppressed and is not executed in the CAD engine. Then we have the invalid status, which is given by this sign. It means that the CAD engine has failed to update or execute the feature during model construction. Last is the out of date status. A sketch entity will have this sign attached to it when out of date. This implies that a feature is out of date and requires updating. In order to display the 3D CAD toolbar, we need to go to Windows, then Toolbars and check on 3D CAD. This will display a toolbar of 3D CAD. This is an alternative method to create 3D CAD. We have repeated many times before as well. For CFD, we require a CAD model. CAD model can be solid filled model as well as only surface model. Dealing with surfaces is known as surface modeling. In this, a three-dimensional geometry is represented using zero thickness surfaces. These are known as sheet bodies. We use such surface, make them closed and extract the interior volume as CFD domain volume. Sheet bodies can also be converted to solid bodies or a sheet body can be created from a solid body. Before using imported CAD models for CFD, we need to repair imported CAD geometries. We need to perform many repair operations on sheet bodies before we use them for extracting volume for CFD. There is extrude operation, revolve operation, loft operation, sweep operation, chamfer operation. We can also create fillets. Other than this, there is Boolean operations and transform operations. Also, we need to carry out other advanced functions like filling holes with sheet bodies, sewing sheet bodies together to form a solid body, and converting a solid body to a sheet body. All this can be done in 3D CAD. So let us explore all these operations in detail. We discussed 3D CAD and CAD models. But how to start creating a CAD model in STAR CCM Plus? All CAD model creation starts with sketches. Sketches are primitive 2D drawings from which we create 3D models by using various sketch operations. What is a sketch? These are two-dimensional profiles that are created on a planar surface. It can start with basic shapes or entities like point, edges, rectangles, circle, etc. All sketches consist of edges and points. Sketches are needed for creating all solid bodies.